When you think of Yellowstone, you probably picture Old Faithful, geysers, and maybe some bison. But beneath all that beauty lies something that has fueled countless disaster movies and doomsday headlines. The Yellowstone supervolcano. Today, we're going to peel back the layers of myth and misinformation to uncover the scientific truth about what is really going on beneath America's most famous national park. Is it a ticking time bomb ready to blow, or is the reality far less terrifying? Let's find out. So, what exactly is a supervolcano? The term itself sounds incredibly dramatic, right? It's not an official scientific term, but it's used to describe a volcano capable of an eruption that ejects more than 1,000 cubic kilometers of material. To put that into perspective, the 1980 eruption of Mount St. Helens, which was devastating, ejected about 1 cubic kilometer. So, a super eruption is at least 1,000 times larger. Yellowstone has had eruptions of this magnitude in its past, which is why it gets this intimidating label. But it's not a pointy, cone-shaped mountain like you might imagine. Instead, the volcano is a massive depression in the ground called a caldera, measuring about 45 by 30 miles. This caldera was formed by a past massive eruption. The reason Yellowstone is so volcanically active is because it sits on top of a hotspot. Imagine a giant blowtorch pointing up at the Earth's crust from deep within the mantle. This is the Yellowstone hotspot. The North American tectonic plate is slowly sliding southwest over this stationary plume of hot rock. As the plate moves, the hotspot essentially punches through it, creating a chain of volcanic calderas. Yellowstone National Park is just the current location where this hotspot is active. If you trace the path of the hotspot, you can see a trail of older calderas stretching across Idaho's Snake River Plain. It's like a scar left on the continent over millions of years, and Yellowstone is just the freshest mark. Now let's talk about the big ones. The geological record tells us Yellowstone has had 3 truly massive, caldera-forming eruptions. The first, and largest, was about 2.1 million years ago. It was colossal, creating a feature known as the Huckleberry Ridge Tuff. It was one of the largest volcanic eruptions known to science. The second major eruption happened around 1.3 million years ago, forming the Mesa Falls Tuff, and the most recent super eruption occurred about 631,000 years ago. This eruption created the Yellowstone caldera we see today and blanketed a huge portion of North America in ash. These are the events that spark all the fear, these massive landscape-altering explosions separated by hundreds of thousands of years. But those aren't the only eruptions Yellowstone has had. In fact, since that last big one, 631,000 years ago, there have been about 80 smaller known explosive eruptions. The most recent of these was a lava flow that happened about 70,000 years ago. These were mostly slow-moving lava flows that filled in parts of the caldera floor. This is a really important point. The volcano's most common activity is not a supereruption. It's much more likely to produce these less dramatic lava flows, and even those haven't happened in a very, very long time. The geysers and hot springs we see today are just the surface-level expression of the heat still present deep underground. So what's happening down there right now? Scientists use a technique called seismic tomography, which is like a CT scan of the Earth, to see what's beneath Yellowstone. What they've found is a massive magma chamber, or rather, a magma reservoir. But it's not a giant cavern full of molten rock like you might see in a movie. It's more like a hot, rocky sponge. The magma chamber is estimated to be only about 5 to 15% molten. The rest is solid or semi-solid rock. For a supereruption to occur, you'd need a much higher percentage of melt, probably over 50%. And all of it would have to gather in the upper part of the crust. Right now, the magma chamber simply doesn't have the juice for a supereruption. Okay, but what about all the headlines we see about earthquakes and the ground rising? These are often presented as warning signs. Yellowstone is one of the most seismically active areas in the country, experiencing 1,000 to 3,000 earthquakes every year. Most are too small for anyone to feel. This is normal for an active caldera. These swarms of earthquakes are usually caused by the movement of hot water and gases through the crust's existing fractures. Similarly, the ground at Yellowstone breathes. It rises and falls as pressure changes underground. Sometimes it rises a few inches over several years, and then it falls again. This is all part of the natural cycle of the caldera system and is not, by itself, a sign of an impending eruption. This brings us to the big question. Is Yellowstone overdue for an eruption? You've probably heard this idea. If you take the time between the 3 big eruptions, about 800,000 years, and then about 670,000 years, people try to calculate an average and say we're due for another one, but that's not how volcanoes work. They don't operate on a schedule or a timetable. Tectonic processes are complex and don't follow neat, predictable patterns. Calling Yellowstone overdue is like saying you're overdue for a car accident just because you haven't had one in a while. It's a statistical fallacy. Geologists are clear on this. There is no evidence to suggest that Yellowstone is due for an eruption of any kind, let alone a supereruption. In fact, there's even some evidence that the hotspot might be in a period of decline. So, how do we know all this? Because Yellowstone is one of the most intensely monitored volcanic systems on the planet. The Yellowstone Volcano Observatory, a partnership between the U.S. Geological Survey, the University of Utah, and the University of Wyoming, keeps a constant watch. They have a dense network of GPS stations to track ground movement down to the millimeter. They have seismometers to detect every tiny tremor. They monitor gas emissions and temperature changes in the hot springs and geysers. If anything were to change significantly, say, a rapid increase in earthquake frequency and magnitude, dramatic ground uplift, and changes in gas compositions, scientists would see it. An eruption wouldn't happen without months, or more likely years, of clear warning signs. We would know long before anything happened. So, should we be worried? The short answer from the scientific community is no. Thank you so much for joining me on this deep dive into the Yellowstone supervolcano. I hope this cleared up some myths and gave you a better understanding of the science. If you found this video interesting, please hit that like button and subscribe for more content that separates science from fiction. See you in the next video.